Hello student, welcome back to the one more session of computer networking and security. In the previous session we have discussed about RSA algorithm. In this session I will discuss about some of the problems related to RSA. So RSA is a asymmetric key encryption technique, or is an algorithm related to public key encryption technique. So public key encryption technique is also known as a asymmetric key encryption technique. In public key we are using public key encryption technique. We are using two keys, one is public and other one is private. So these are the steps which I had explained in the previous session. So these are the steps to generate the key. So here in the key generation process, given two numbers P and Q, you need to calculate first given two numbers, both are prime. You need to calculate n is equal to P into Q, that is product of P and Q. Then you need to calculate Euler quotient, that is pi of n is equal to nothing but P minus 1 into Q minus 1. Then you need to select the integer e, calculate d such a way that d is nothing but e inverse of 1, e inverse mod of phi of n. Then you need to calculate the public key and private key. So once you calculate the public key and private key, then so you need to encrypt the plain text by raising the m raised to power e, then decrypt the ciphertext by raising c raised to power d. So in this session we will see how to we will take a problem and we will try to solve the problem. So the given statement is P is given 17, Q is given 11, N is given, so M is given 88, M is nothing but plain text, and E is given. So first we need to find out what is public key and what is private key. For that, what is the first step? First step is you need to calculate N. So the first step is you need to calculate N. So N is equal to P into Q, that is 17 into 11, nothing but you will get a 187. Second step, you need to calculate the Euler quotient, that is phi of n. Phi of n, that is nothing but P minus 1 into Q minus 1. So here the value of P minus 1 is, here the value of P minus 1 is 16 and Q minus 1 is 10. So you will get here 160. Now the value of E is given. So now in order to derive private and public key, you need to derive D. So the formula to derive D is, we know D into E is equal to 1 mod pi of n, or D is the inverse of E minus 1 mod pi of n. So D is equal to 1 mod pi of n. So let us substitute this value in this equation. D, we have V is equal to 7. So we will get E is equal to 7D. 7D is equal to 1 mod, so phi of n. So here you can use the Euclid's method to solve this equation to find out D. So otherwise I will write this one in another way. This is nothing but I will write something like this: 23 into 7, that is nothing but 161, that is equal to 1 mod pi of n. So 23 into 7 is equal to 161. 161 is equal to 1 mod phi of n, because we know 161 is equal to 1 mod phi of n is nothing but 160, 1 mod 160. So this 161 equal to 1 mod 160 gives 1. modular operation gives 1. So here this is satisfied by this 23, this is satisfied by this equation 23 into 7. Anyway, we have taken E is equal to 7, so value of D is equal to 23. So value of D is equal to 23. We got the value of D is equal to 23. Now let me write public key and private key. So the public key is let me write here public key. The public key is nothing but K, U and N. So in my case I will take public key is equal to 3 into N. N is nothing but 187. So private key is KR into N, that is nothing but KR is in our case we got 23 into 187. So any one of the key, either you can take 3 as public key or 23 as public key, so vice versa. So now in the next step we need to encrypt the message. We got public key is equal to 3 187 and private key is equal to 23 187. So student, now we will see how to calculate ciphertext from the plain text. So we have message M88 and encryption process we are raising M to the power 2 E mod n, that is nothing but ciphertext. So substitute the value, that is nothing but 88 raised to the power 7 mod 187 and this gives the answer, that is nothing but 11. So our ciphertext is 11. Now the decryption process, ciphertext is 11. Now the decryption process. So let me write here decryption process. The formula is, you will get the plain text, that is M. You have to raise the ciphertext to the power D, that is our private key, mod n. So the value of C is 11 and D in our case D is, here you can see D is 23. So 11 is raised to the power 23 mod 187 and when you solve this one 11 raised to the power 23 mod 187, you will get the answer 88. So 11 raised to the power 23 is a very big number. Let's try to solve this one. So I will use the calculator. So 11 raised to the power 23, it's a very big number. Okay. Then mod 187. So if you can't solve it by this one, you have to split the process 187, you will get 88. So we got the answer 88. So this is the first problem. Now we will see the other problem related to RSA. Now we will see one more problem. So next category of problem. So let me write the problem here. That is, apply RSA and encrypt and decrypt the message. The problem statement is, here given A is equal to 3, B is equal to 11 x is equal to 3 and m is equal to 9. So here a is equal to 3, b is equal to 11. In term, it is nothing but a is nothing but p, that is p is equal to 3, b is equal to q, q is equal to 11, x is equal to 3, x is nothing but it is our one of our key, that is public key 3, and m is message. Sometimes the problem will be given like this. So now first step is you have to find out the n. N is equal to p into q, that is you will get here the value 3 into 11 is nothing but 33. Then you have to find out phi of n, that is nothing but p minus 1 and q minus 1, that is nothing but you will get 2 into 10, that is nothing but 20. Now we have the value e, we need to find out d. So the formula is d into e is nothing but 1 mod phi of n. So here we know e is 3, substituting the value e is 3, we will get 3d is equal to 1 mod pi of n, that is 3d is equal to 1 mod pi of n is nothing but 20. So in order to solve this one, I will take the value of 3d is equal to 21, that is 3 into 7, that is nothing but that will satisfy this equation 1 mod 20. So the value of d is equal to 7. We got now public key and private key. Let me write here public key. So public key is equal to kun, that is nothing but kun, that is nothing but 3 in 3 comma n is the value of n is equal to 33, and private key is private key is private key is nothing but 7 comma 33. So now you need to encrypt the message, given message, encrypt the message. The formula is C, ciphertext is nothing but m raised to the power e, public key mod of n, that is we have message m is equal to 9, 9 is raised to the power 3 mod of 33, that is nothing but you will get 729 mod of 33, and you will get the answer C is equal to 3. You will get the answer C is equal to 3. Now we got C is equal to 3. To get the plain text, you have to encrypt, decrypt the message by raising C to D mod of n. So in our case C is 3 raised to power 7 mod of 33, that is nothing but you will get 2187 mod of modular of 33, and the value you will get is m is equal to 9. Original message we got back. So student, in the next session we will discuss some more problem, but something in complex problem. So thank you for your cooperation. Thank you.